Okay, here we are, Chapter 2, Section 2, Inductive and Deductive Reasoning. All right. Now, again, a lot of people complain about certain math being not relevant or not useful in real life, but this is one of those things that really is a big part of what people do on a day-to-day basis. Entire jobs, careers, and industry are based upon these kind of two concepts. And since most of us don't use them on a regular basis, it's easy for us to get them backwards. Okay. So we're going to go ahead and go through some of these two main types of reasoning called inductive reasoning and deductive reasoning. Okay. Now, inductive reasoning is what you're probably used to doing as a person, as a human being, and as a young person. Okay. What you are left with when you use inductive reasoning is that you basically have a lot of different examples. You have examples of this person doing this, examples of this person working, examples of this scenario working out, and examples of this one not working out. Okay. And you take all these examples and you reach a conclusion that creates a pattern for you, right? It creates a pattern for you, right? So you say, okay, well, I know a person who lied and then they stopped becoming their friends. And you knew a second person who lied and then they lost a bunch of friends. And then you know a fourth person who lied and they lost a bunch of friends. You might come to the inductive reasoning result because based on your examples, your specific examples, that in general, when people lie, they often lose friends. Okay? Now, that is an inductive statement, an inductive reasoning. You're taking the examples that you see, okay, and then you put them together to reach a valid general pattern, okay? We call this conjecture. Now, I know that the word conjecture gets a lot of bad rap, but again, it's usually given these positive and negative feelings based on people who don't know what they mean. They get them confused between what they're talking about. Okay, there is a need for conjecture. There is a reason why conjecture exists. It is how human beings generally learn and things. Okay, you learn the patterns, right? If even a dog, I mean, for example, learns conjecture, right? Every time the dog barks when you're watching a show and he gets kicked out of the room, he stops. Then he does it again. You do it again. You do it again until pretty soon the dog learns that every time he does something, every time this specific example comes up, then he gets the consequences of it. He gets sent outside. All right. So that's the issue. Okay. That's what conjecture is. That's how learning takes place. Okay. Now, one of the reasons why conjecture gets a bad rap is because it could easily be disproven. Okay. It could easily be countered. Right. We call the opposite of a conjecture a counter example. Right. So I'll go back to my two previous examples. Right. If every time the dog barks, you kick them out. Okay, they're going to learn a general pattern. Okay, but if one day he barks and you don't kick him out, well, then he's not going to learn the pattern, right? If I say, okay, every time I see one of my friends lie, they lose all their friends, and I say to you, well, yeah, but I knew people who lied to me and I was still their friend. See, that's a counter example of what your experiences show, right? So I don't want people to believe that conjecture is a bad thing. It's a good thing. It's based upon people's experiences, and when you're young or inexperienced, that's all you have. Okay, that's all you have. Now, this is all different than what we might call deductive reasoning. Okay, in inductive reasoning, we start off with specific examples and move towards a general pattern. In deductive reasoning, we start with general facts. Okay? So deductive reasoning, what we call logic, okay, is often more associated with math and science, but truthfully, both of these are true, okay? And both of these help us on a regular basis, okay? Logical arguments are based upon not my experiences, not the things that I know or that I think are true, but rather facts that are widely accepted. Okay. The sun rises in the east. Okay. That wasn't my idea. I didn't make that up. That is a general fact. Okay. So if you see the sun rising, then the direction you're seeing it from is the east. Now, how did I know that? Because its general fact is it always rises in the east. Therefore, making the logical argument that if you saw the sun rising in the east, that you're facing the east, this is what we might refer to as deductive reasoning. This is a little bit closer to what we might call Sherlock Holmes, okay, or even CSI, okay, when they use science or general facts to help deduce a specific examples, right? Knowing that whenever somebody lies and steals something from the police know how people act when people lie and steal stuff. Therefore, when they meet people on the street who are acting that same way, it is very logical for a police officer or a city local law enforcement officer to very logical to make the conclusion that if this person is acting that way, they must be, again, lying or cheating or something like that. Okay. Now, there's two other subparts to this. We'll go into more details when we go through the work together. But one of them is called the law of detachment. Okay. In other words, if the hypothesis is true, the conclusion is true. These are true statements. Okay. This is called the law of detachment. You can use this in logic. Okay. Right. If something is true, then the conclusion is true. Right. If I want water and then I drink water and know now I'm no longer thirsty. Okay. One true statement is based upon the other true statement. That's the law of detachment. Okay. The other law referred to in logical arguments is referred to as the law of syllogism. Okay. This is more like the transitive property, right? If P is true and it becomes Q, and Q is true and it becomes R, then clearly P becomes R. Radio. And again, I go back to some detective work or to CSI or to some of those of you who read or at least know the stories of Sherlock Holmes. This is what he's doing here, right? This is the kind of logic he's doing. It's not complicated. It's very basic logic, right? If you know, if the doctor wanted the nurse dead and the nurse died, then therefore the doctor, wanted the nurse to be killed, right? It killed the nurse. All right. So, at any rate, inductive reasoning and deductive reasoning, our main goal here is to not get them confused. Inductive means you start from a very specific examples, your personal examples usually, and you build a general pattern, right? When I say Republicans are like this or Democrats are like that, that is not logic. That is not using logical reasoning because I do not know every single Democrat in the whole country. I do not know every single Republican in the whole country. Okay. All I'm doing is using specific examples and I'm making a general pattern. That's called conjecture. Okay. And in politics and in people's daily life, conjecture is very popular. Deductive reasoning is what we like to move towards, especially in math and science, but both are valid ways of reasoning. Okay, let's go ahead and practice a few questions here because that's really the main point here, right? So, first, let's take a look at this. Make and test a conjecture about given quantity, right? So here's our statement: the sum of an even number and an odd number. Okay, they're telling us something is happening. The sum, that means we're adding together an even number and an odd number. What general conclusions could we reach? Right? If we add together an even number and an odd number. Well, one thing we could say is the sum of an even integer and an odd integer will become an odd number. Okay? Think about that. Adding together an odd number and an even number, would that make it automatically odd? Maybe. I don't know, but that's my conjecture. I'm using these examples here to come up with a general pattern. How about the integers will be positive? I don't know that either. Okay, but it's a conjecture. I think it might be true. It would be a reasonable thing to assume based upon our statements, right? Here's another thing. The sum of an integer and an odd integer will be greater than 100. I don't know if that's true. I can think of some examples that'll make it true. Some will be true, some will be not. Okay, but these are examples of conjecture. Okay, Again, we're not talking about truth here, okay? We're talking about possible outcomes based upon our reality. Now, some of them are true, right? The first one is true. The second one's not true, and the other one's not true, but that's okay. They're all conjectures, and that's what we're practicing with, right? Let's take another look at another one. Find a counterexample to show that a conjecture is false. So here's an example of a conjecture. The product means multiply. The product of two positive numbers is always greater than either number. Okay? So if I take two numbers and multiply it, the answer is going to be bigger than either one of those numbers. Oh, well, that makes sense. 2 times 4 will be 8. Okay? 8 is obviously bigger than 2 or 4, right? 3 times 6 will be 18. 18 is obviously bigger than 6 and obviously bigger than 3. Okay, that makes sense, right? That's conjecture. I get the examples. That all works out. But our job here is to find a counterexample. An example where this seems like it's true, but it's not actually true. For example, I use fractions. Okay. 1/4 is equal to 1/2 times 1/2. And 1/4 is not bigger than 1/2 or 1/2. A quarter is less than a half. This is an example of this exactly being wrong. That you can, in fact, multiply two positive numbers and the answer will be smaller than either number. And I came up with this example, and that's my counter example. Okay? That's what we're working on in today's assignment. Now, let's take a look at a couple more basic stuff here. Is this inductive or deductive reasoning? Let's take a look. Even numbers are divisible by 2. That's my experience. That's what I know. Odd numbers are not divisible by 2. That's my experience. That's what I know. And then I reach the conjecture. That means 4 is an even number. Okay? Now, does it mean that? Does it not? It doesn't matter if it's true or not. But let's consider. I'm using my personal knowledge of two things that are true. Okay? And I am putting it together to create a general pattern. And that is called inductive. Each time you clean your room, you are allowed to go out with your friends. That's a factual statement they're telling you. So the next time you clean your room, you will be allowed to go out with your friends. So we start with the facts, and then we reach a conclusion based upon that facts. That's all we really need to know to realize that's deduction. All right. Now, if you have any other questions, you go ahead and ask for help. Come to tutoring or ask another teacher. Thank you.